So they give us a graph of f of x, and they want us to sketch the graph of y plus 4 equals f 1/2 x plus 1. The first thing I would probably do with this equation is I would look, yes, it is in factored form. I would move the 4 over to the other side. Because we've always talked about things inside and outside of the function. And next, I'm going to look at each of the numbers and describe what they mean. So this half would be, because it's inside the function, horizontal, a horizontal stretch. That tells us we're going to multiply our x values by 2. The next number is the 1 inside the function. That's going to go 1 to the left. And finally, the minus 4, horizontal translation, is outside the function. That's a vertical translation. That's going to go 4 down. If you have your red pen, I would like you to draw in the asymptotes on this graph as well and label them at x equals 0 and y equals 0. These are 2 important points. Even though they've labeled 2 other ones, I'm going to use the ones that we would typically use. Can you see that this is a 1 over x graph? That our actual equation is one of the ones from our colored sheet. This is the blue sheet. This is our 1 over x graph. If we're doing our 1 over x graph, we would use the points 1, 1, and negative 1, negative 1. Because we have stretches and compressions, if we're showing our work, we're going to take our points, draw arrows first for stretches, then arrows for our translations. What are our stretches? We only have one stretch. X is getting multiplied by 2, but we have 2 translations. We have 1 left and 4 down. So when looking at where do these points go, if my x values are multiplied by 2, that would give me 2 and negative 2. My y values didn't change. And then 1 to the left, 1, negative 3, 4 down, negative 3, negative 5. Again, when you're doing the mental math, double check each one, do it slowly. Make sure your points are matching up. And the other thing that's going to happen with an equation with asymptotes is you're also going to look at where did the 2 asymptotes go. And because the asymptotes start at 0, multiplying them by anything won't make a difference. The only thing that's going to make a difference is if you move left, right, up, or down. Moving 1 to the left, can you see that that would take the vertical 1 and shift it 1 to the left? The vertical 1 was at x equals 0. If I move 1 to the left, it will now be at x equals minus 1. Your horizontal one, the only way that one's going to change is if you move it up and down. We're moving 4 down. Can you see that that asymptote will become y equals negative 4? So anytime you have a graph with asymptotes, you have to find out where those asymptotes are going to go. So in this case, what we're going to do is we're going to draw our final graph off to the side. And the reason I'm going to draw it not on top of the first one is because with asymptotes and dotted lines, it just gets too busy. So let's draw it on a separate graph. We'll start by drawing our asymptotes. We have an asymptote now at x equals minus 1, and we have an asymptote now at y equals minus 4. The points that I need to add are 1, negative 3, and negative 3, negative 5. Once you have those points, things have to go towards the asymptotes, and we'll be able to draw our final graph. One of the things that I want you to see in this question is this question was done all in function notation, right? The original they just told us was some function y equals f of x, and then our image was y equals f of 1/2 x plus 1 minus 4. That's function notation. We could get this same question in explicit notation. And sometimes it's helpful to be able to move between the two. So if this was explicit notation, we would say, oh, I recognize the original, here I'll write it the same way, the original was y equals 1 over x. And so what are we noticing between the original in function notation and the original in explicit notation is that basically we're replacing the function with 1 over x because we recognize which one it is. Now, what would be the explicit notation for the image? And this is where it's helpful to be able to look at the function notation and be able to change from the function notation to the explicit notation. Because you could get this same question in explicit notation. So it's going to be y equals, just like y equals on this side, but instead of the function, and I'm putting the function in blue here, instead of that function, we need to write that as explicit notation. And what's the relationship? The relationship is right here. Whatever is inside the function in function notation has to replace the x in the explicit notation. And you've done this before. If I ask you if f of x was 1 over x, and I said, what's f of 2? You would say, oh, I plug in 2 for x, I get 1 over 2. If I say, what's f of 10? You'd say, oh, I replace the x with 10, I would get 1 over 10. So what is f of 1/2 x plus 1? We would replace the x with 1/2 x plus 1. We have a minus 4 after the function. We would still have a minus 4 after the function. The question for you is, if they gave this question in explicit notation, would you recognize the half here as a horizontal stretch, a horizontal translation, and a vertical translation? Would you recognize that all of this was inside the function? I find function notation is really easy to see what's inside the function. Because when you have function notation, there's your function, there's something inside of it. Really easy to see. A little bit more difficult to see what's inside the function when we get to the actual equation or the explicit notation. Okay, questions for practice on this one? Please circle 7 and 11.